Hello, everyone. Welcome, and thank you so much for joining us today for the Greenhouse Heating Options webinar. I'm Janine Wright, Senior Communications Specialist at Prospient, and I'll be your moderator for this session. We're excited to have you with us today. And before we dive in, I just want to mention real quick our next upcoming webinar so that you can mark your calendars. It's going to take place on October 22nd. It's called Dear Grower, Let's Make This Greenhouse Happen. This webinar is the third installment in the Dear Grower webinar series that kind of focuses on all the different steps of building your greenhouse from the minute you call your salesperson to working with suppliers and contractors and finally having a functioning greenhouse. So mark your calendars for October 22nd and watch for an email with more registration details, or you can sign up on Brightbook. So for today's session, feel free to enter your questions into the chat at any time. We'll leave some time at the end to answer questions and may answer a few as we go along, but feel free to put those in there anytime. So now I'm excited to introduce today's presenters. We have with us Jared Freyer, our MEP Systems Manager, and Paul Golden, Sales Director for Commercial Growing. They'll be taking us through today's topics, so I'm going to turn the time over to them and let them tell you a little bit more about themselves before they get started.
Thank you, everyone, for joining. As Janine had mentioned, I'm the Sales Director for the Commercial Division of Prospient. So we work primarily with wholesale growers, retail garden centers. To some degree, we work with high schools and some R&D facilities as well. And so we see a large number of different heating schematic or heating systems within the greenhouses, and for every type of application, basically.
Yes, and my name is Jared Freyer. I am the MEP Systems Manager for Prospient. And what I do is our group, we design all things greenhouse heating, HVAC, as well as all other systems that you would see within a greenhouse, including irrigation, CO2, lighting, benches, controls, etc. But today what we're going to do is we're going to focus on primarily the heating systems that we would see in a greenhouse and how we would approach that design.
So to give you a quick overview, we're going to talk about the two most common types of heating systems here today. First and most common is probably the forced air heating system, and then also the hydronic hot water heating system that is predominant in larger operations. We're going to also kind of talk a little bit about how you would go about choosing the system, which one would be right for you. And like we mentioned, please feel free to ask any questions throughout the course of this. Jared, do you want to start with forced air heating systems?
Yes, absolutely. So starting with forced air heating, which is also unit heaters is what we most commonly call it as for greenhouses. Starting with this would always be our base option package for heating a greenhouse. It's easy to use, compact. It's going to be your most budget-friendly option, and basically it's just kind of a get it done type of heating system. It provides the heat that you need in a cost-effective package. The only piping that you would have to route in the case of gas unit heaters is the gas piping itself. Electric usage is very low. And then the way it works is the unit heater itself, it's ductless. Now we can attach a poly duct that runs overhead. There's various options that you can use with it, but typically it's ductless, and it's just going to blow forced air throughout the greenhouse that's heated. We can go on to the next slide.
So one of the nice things about the overhead unit heater system is it doesn't actually take up floor space, but also one of the downfalls is it does create some shadowing. You do want to make sure before you install one of these, especially if you're installing them on a ground-to-ground style greenhouse, that you can't actually support the system off your structure. I have seen people do some workarounds in the past where they've had them on stands. For the most part, almost all greenhouse structures are really going to be able to handle that additional loading, but you definitely want to ask a greenhouse professional before you go to try to hang it off your structure, just in case it's an older structure and it wasn't ever designed for that kind of dead load. So we have the basic types of units we have are power vented, and we'll expand on what that means here in a second. Separate combustion and power vented. There's also high efficiency condensing units, and there's also units that run off of either steam or hot water. So, when you walk into a greenhouse and you see a unit heater, a big box overhead, there's several different methodologies or several different types of systems that could be. It's not just one size fits all. So to talk a little bit about some of the common pitfalls I would recommend is to avoid, and the things that we see is, these units come in discrete sizes. So typically they're sized in 50,000 BTU blocks from 200 or 150,000 all the way up to 400,000. Usually they're limited at the 400,000 BTUs. And some of the times what we see is just incorrect calculations to start with. No one ever really put a pen to paper to figure out the size of the units that they actually need and what type of delta T they can expect to have inside the house. But the other thing is, when we're talking about efficiencies and cycling of these units, if you have them too large or too small, then they tend to cycle a little bit more and be a little less efficient to use. So, for example, let's just say you only need 200,000, but you have a 400,000 BTU unit. It's going to turn on for a short period of time and then turn back off again, and then cycle more frequently than probably the 200,000 or 250,000 BTU unit that would kind of stay on more consistently. So that's something to consider. Wrong locations and arrangements are something we see oftentimes too. It's not uncommon for us to see people try to save some money by not having to run as much gas line. And typically what they'll do is they'll put more than one unit heater on the same end of the greenhouse, and then kind of relying on mixing fans to get that heat to the far end, or maybe oftentimes we see two unit heaters put on the intake side of the greenhouse, so the pad wall side or the vented side, and then they have nothing on the exhaust fan side, and it might be a 150-foot long greenhouse. So obviously there you're not getting great uniformity with that design. It's most common to put the unit heaters in a raceway track if you're going to have more than one. And so you have them kind of blowing in a circular direction along with your horizontal airflow fans. Obviously, if you don't have horizontal airflow fans, you just have vertical mixing fans. It's even more important that you place the unit heaters on each end of the greenhouse versus just one end. Lack of redundancy. So one of the nice things about running a larger facility with unit heaters is that you typically end up having multiple unit heaters to meet the heat load requirements. But if you're just running a single house, let's say, for example, your small R&D greenhouse or high school greenhouse or something of that nature, and you only have one unit heater, what do you do when that one unit heater has a chip burnout or a fuse go out on it or something of that nature, and you actually have no redundancy? So a lot of times, let's just say, for example, we have a greenhouse that requires a 400,000 BTU heat requirement to maintain a 50-degree delta T. What we oftentimes might do is we might size two 300,000 BTU unit heaters so that maybe we're not meeting the full redundancy, but we would have stage heating. So one unit might turn on first, and then the second one would support that first one when you get into the extreme cold temperatures of the year. And should one unit go out, maybe you're not maintaining that full 50-degree delta T, but you're certainly not freezing or losing crop by having two 300,000 BTU unit heaters when you only really require one 400,000 BTU system. Jared, you have anything you want to say about that?
Yes, absolutely. The key with sizing is, like you said, you don't want to oversize. A lot of people are worried about, making sure that you're covered for a worst case scenario. Now, it's one thing to have, if you have multiple units, you can designate some units in your control strategy for redundancy. That is perfectly fine. But you don't want to oversize, say, large unit here for a small space because of that cycling issue that you went into earlier. And then the placement is also important as well, making sure that you account for what we call the throw of the air that comes out of the unit here, making sure that it can reach all the spaces adequately and that you have even distribution. So a larger house, like you said, it may be better to divide up into two 200 MDH unit heaters instead of a single 400 one. We can going on to what we were describing earlier with the power exhausted versus separated combustion unit heaters. Those are going to be your two main types of gas unit heaters. So we're talking about gas unit heaters here and how the combustion chamber and flue venting is organized. And the power exhausted type of unit heater, that is going to be your standard base design. And what that does is it has a single flue vent that's going to exhaust the flue gases to the outside, but there is no combustion air intake vent. It actually pulls in combustion air from inside the greenhouse itself. And then in the separated combustion example, that unit heater is going to have two flue vents, one for the exhaust going outside, and then a second one that also goes outside that pulls in combustion air. And this one, what it does is it creates neutral pressure within the greenhouse, and a lot of the higher efficiency models of unit heaters also are going to use that separated combustion type of arrangement. And then going into the efficiency, kind of segued into the last one. Our standard efficiency unit heaters, they are going to be what we call non-condensing, so they won't have any condensate piping that comes out of them. Typical standard efficiency unit heaters are going to be about 82 to 85% efficient. But what we see more and more demand for are high efficiency unit heaters, which are operating between the 92 and 97% efficiency range. And the way they work is they condense. And by condensing, I mean there's condensation that forms in the flue gases itself because it draws more energy out of the flue gas, so brings it to a lower temperature in which water will condense out of it. So one thing you have to be aware of when you're working with high efficiency unit heaters is that you have a separate condensate piping line that you can route to.
And that condensate is typically slightly acidic, so you want to keep in mind too that anywhere you run, typically you have a filter or scrubber of some type that helps reduce the acidity level. And if you don't drain this properly, pipe it out properly, and you have it just piped right to the concrete slab, or it touches any part of the greenhouse, what you see oftentimes is corrosion from that condensate.
And then next we can jump into the hot water radiant heating systems. So this is going to be our next level of heating systems that we have for greenhouses. Kind of going into, like what we're talking about with the unit heaters, some of the why that's a base option and why this is an upgrade option for this hot water radiant. One of the cons of just using forced air heating unit heaters is you inherently, even if you have good distribution of unit heaters, you're still not going to have perfectly even heat distribution within a space. And then also all that forced air, depending on the crop that you're growing, can have a tendency to dry out the plants because you're using a lot hotter stream of air that can blow directly on the leaves, depending on how it's oriented. And just based on the hotter streams of air coming out of the unit heater, you're going to have a little bit of uneven heat, but more so uneven humidity, especially in the wintertime. You're going to have pockets of humidity and then pockets of really dry areas that's right inside the path of unit heaters. So the upgraded option that we see on a lot of both institutional and commercial grow facilities is what we call hot water radiant heating. This does not use any forced air. What it does is it uses hot water radiant heating elements, either heat pipe or fin tube, to both radiate heat outward in a more gentle sort of way. And there's also some natural convection that takes place as well on these units. And what you're going to have is these radiant elements are going to be distributed across the entire greenhouse space along the perimeters and overhead. And you're going to get a much even, not only even heat distribution, but you're also not going to have pockets of dry areas from forced air being blown around in certain areas.
So one of the things I find is a huge benefit as a larger grower, is that with a centralized heating system, there's, from a maintenance standpoint and from a basically maintenance standpoint, you're always able to kind of go to one point and look at it. I used to operate a greenhouse that was over an acre, and we had, I believe, 16 or 20 unit heaters. And in the winter months, I would have to go look at most of these unit heaters to make sure they were actually still operating properly because I didn't have a feedback loop in my control system telling me, hey, this one unit heater in house number 7 is down and it's not turning on when I send a signal to it. So I would have to go from, on a regular basis, I'd have to walk around, and, when you have 16 unit heaters, that's 16 motherboards to have to worry about going out at some point, because they eventually will, fans, bearings, and all that other stuff, versus one centralized computer system within the boiler, or within the primarily within the boiler to have to maintain. So I would argue that the lower maintenance requirements of a hot water heating system really starts to pay off as you start to get more and more, as you start to get larger and larger, as you start to get size of your facility for more and more heat. If you were to do the same amount of heat with the unit heaters, the maintenance is what really tends to do that system in. So some of the methodologies for delivering that heat, that hot water heating, is both under the bench, in the floor, perimeter, so around all 4 walls, exterior walls typically, under the gutter, so this would be on the interior gutter runs to help melt the snow, and then pipe rail, which is primarily, it's also a transport mechanism for primarily produce operations. So you can use the heat pipe that sits basically on the ground. It's on a stand that's at the ground level, and that could be used for transporting carts of produce back and forth, carts and people for that matter, back and forth throughout the house.
Absolutely. And we'll get in a little bit deeper in the next couple of slides on those various delivery methods and location. Going into this next slide, kind of reiterating what I had said earlier about the benefits of the radiant heating system compared to unit heaters. Gentler, softer heat, modulate. And one thing I didn't state earlier is also there's the ability to modulate this heat delivery. So not only is it distributed evenly, but the modulation itself reduces some of the cycling that you may experience with unit heaters, where you don't have this on, off, but the control system can actually detect what that appropriate radiant element hot water temperature should be to maintain that space, and you'll get a much more even, from a time standpoint, not only area standpoint, but also a timing standpoint, even heat delivery throughout the day. And then the different other benefit would be, like we said, with the different delivery methods of the targeting zone. Unit heaters are typically only overhead. There are a couple unit heater arrangements where you can have them under bench via ducting. You can work underneath the benches, but again, that same, if you do that with unit heaters, you still run the risk. If you don't control that temperature in the ducting, you still run the risk of overheating and drying out your roots. Whereas hot water radiant heating, when you deliver under the bench, which is a common means of delivery, again, you still have to control that temperature, but you're not going to have the risk of drying out the roots, and it's much easier to maintain a more milder, gentler temperature underneath the roots to prevent that burning. And then the humidity levels, like I said, you don't have these pockets and the streams of air that are going to dry out the plants. So more so, it gives you more even humidity.
And I would argue that under bench heat or root zone heating is more of a crop steering tool than other forms of heating that are out there. So, say for example, forced air. This is sure, it's heating your space. It's doing that benefit that you need. It's keeping your space from freezing, keeping the leaf temperature at the target temperature, but it's also driving growth. And so that's one thing that's different. I mean, everyone needs heat, right? More or less, everyone needs heat in the greenhouse, but this is a crop steering tool almost.
That's right. Now we can get into different type of delivery methods and types of radiant heating elements themselves. First, we'll go into what we're going to call radiant fin tube. This is typically going to be aluminum, what we call aluminum fin tube. So it's aluminum piping with aluminum fin on it. This is going to be very popular for institutional greenhouses as well as some the smaller commercial greenhouses. I would say up to maybe 1 to 2 acres in size. And one of the benefits with this, first and foremost, at least with institutional jobs, is the aesthetics of it. Being an aluminum on aluminum, it matches the same material that we have of the aluminum structure that we often use for institutional greenhouses. So you're never going to see any of that corrosion that you'll see in other types of heating methods. There's other radiant elements out there that are used common in say the building industry, not greenhouses, but the building industry, that are copper fin tube. And I've seen them used in greenhouses, but we don't usually push that method, because anytime I walk into a greenhouse that's more than 10 years old that has copper fin tube, it's green. It's green. It still functions fine, but it just does not look bad. It's green and black and all discolored and everything, just because of the higher humidity levels that you have in space. The aluminum fin tube looks pristine after 10, 15, 20, 30 years. It looks the same. It does not change. So aluminum is definitely going to be our preferential method there. As far as the water chemistry, you do have to be aware of maintaining the water chemistry specific to aluminum piping system, but it's just as simple and easy as any other hydronic system you maintain. You just have to, the actual corrosion inhibitor that you put in the system and maintain, you just need to make sure you have the one that's also for aluminum systems. And we provide that whenever we design these. And then on commercial, so what you see here in the picture, this is a perimeter fin tube system. It is our SF fin tube product. We also have other types of aluminum fin tube. We have what we call twin fin, which are fins that run axially down the tube. And those we typically use in underbench applications and distribute them evenly under the benches. They're going to be more common in commercial layouts. We can also use that same fin overhead as well as this overhead as well. This SF fin that you see here, it's going to give out more BTUs per linear foot, so you don't need as much of it. So that's why, for institutional houses and perimeters, it makes sense that way. But if you're in a commercial house, you're not worried about how much linear feet you have available to run it. Looking at one of those other methods might be appropriate as well. And then we can go into the next type of radiant system that we use, which is what we call radiant heat piping. So this is as simple as it's described. The heating elements themselves are the pipes. It's the same type of pipes that we use to, deliver the heat in the mains and branch piping. And as you can see here in the picture, this is actually of a manifold pumping and valve control station. And the little silver parts that you see around the pumps, that's going to be your mains and branch piping that's insulated. So we insulate that piping so that we don't radiate heat in the wrong areas. Once you get to the top of it, you can see where it's white. That is uninsulated. That then begins to go throughout the radiant heat piping itself, that then delivers throughout the greenhouse. And you can see a lot of pipes hanging on that sidewall there. That is a portion of the piping, what we call gable heat piping. And then it also goes out from there. There's going to be rail cart heat piping, crop heat piping. And all this is typically, there's two main sizes of piping that we use. Either we call it 51 millimeter OD or 38 millimeter OD. And it's just bare steel pipe. It's painted so that the painting itself, that's what's going to prevent it from corroding. And then it just radiates out. The market that we typically use this in is going to be large commercial greenhouses and produce. I would say typically more than 2 acres in size is going to be your better benefit for it. And the reasons is, it does give you more even distribution, and this piping does better for larger spaces because of the size of the piping and the flows can carry longer distances. The piping itself does not radiate as many BTUs per linear foot as fin tube does. So you wouldn't want to use it in small greenhouses, small commercial, institutional. It just, the flows don't work out that well. But in large spaces where you're running 100 meters, 125 meters down the space and back, and your loop's maybe 250, 300 meters long, you want an element that actually radiates a much lower amount of BTU per linear foot, so that you don't have really wide heat loss within that single loop, and you can maintain the temperature within those piping loops. And then also from a large scale perspective, it is going to be more cost effective and more lead time effective as well, because there's no special manufacturing that's involved for these elements. It's just the same piping material that we order for the rest of the piping. So we can get this from our vendors in large quantities. And like, for example, we may have a greenhouse, I'm trying to think the exact acreage of it. It was about maybe 10 acres in size. We ordered 50 to 60 miles of 51 millimeter pipe. So you can kind of, which is not a problem. It's, we can get these straight from the vendors, straight from the extruders that way. But if this was a fin tube system, yes, we would use less fin tube. I'd say about a quarter as much fin tube would be required. But even still, that would not be something that you would be able to get at that type of scale.
And we're talking about a different cost too, right? So you have the aluminum cost versus steel costs. Yep. One of the big differences between these two types of systems is really in the install. So on the steel system, the 51 millimeter piping, more often than not, it's completely welded together in the field. And, that's not, people sometimes get scared about that, but when you're doing it at a scale, it's much less costly than doing it with a bunch of fittings like you would see on an aluminum system. So aluminum system, you're not necessarily welding much on that. You tend to have a bunch of couplers that attach sticks of the aluminum fin tube from the manifold all the way to the return. And so, yes, it's quick to install the aluminum system. That's one of the pros of it. It's really quick to install, but when they're doing it at scale, it makes more sense to get a welder out there to the site and have them weld the pipe up. And actually you could do that at a much lower cost when you start to talk about a larger scale.
Absolutely.
Oops, sorry, Jared. I skipped ahead. So one of the most common forms of heating that we see.
The final system that we have.
Yep, there we go. Sorry. So one of the most common types of heating systems we see is the PEX system here, the in-floor heat system. Very, very common with flood floors. Also pretty common just in anywhere you want to have the ability to evaporate any water that touches the ground pretty quickly. So we'll see this on a number of different institutional or very high-end greenhouses, sometimes even in a retail space where they're just worried about somebody slipping on some water. So this will help evaporate real quickly, creates a very comfortable environment. It also helps you steer your crop when you actually have the crop on the ground. When you start to raise your crop off the ground, it becomes less necessary to have the PEX in-floor heating system. But we see it in almost every type of market. It's very common with the large wholesalers. It's common anytime you have a container touching the floor. It helps to drive plant growth, drive the root ball a little bit more, so you have more irrigation opportunities. And it's a pretty flexible, no pun intended. It's a pretty flexible system. We can add capacity to it. In the planning stages, that is, not once it's sunk in the ground, but we can add capacity pretty quickly. And it's also very, very resilient. The one thing I'll say about the in-floor heat system is that if you plan on installing equipment into the greenhouse and it needs anchors, you have to very, very carefully mark out where the PEX is in the floor, because the last thing you want to do is have a penetration of that PEX system once it's been installed under the concrete.
Absolutely. And a couple other things to keep in mind with this, like you said, it is very flexible. We can offer it in various widths as far as how closely you space the PEX tubing together. Our standard for most of our large greenhouses, any large commercial or produce greenhouse, is going to be 12 inches on center. So all the pipes are always going to be spaced 12 inches apart, and that gives you a nice heat load for a concrete space without overheating the floor. Typically, we don't want the concrete temperatures to go above about 95 degrees Fahrenheit because of the same issue with if there's plants on the floor or something like that, we want to make sure that it's both comfortable, but also we don't have root burn or over drying the roots that way. But it's also flexible to use in smaller institutional jobs. And those jobs where the footprint of the greenhouse is smaller, we may have a lot higher heat losses along the perimeter of the slabs. So what we can do is we can space that PEX closer together, often 9 inches on center or even 6 inches on center towards the exterior surfaces where you have the greater heat loss. And then in this picture, what you see here, this is going to be a typical commercial or produce greenhouse type of delivery system where we have the delivery manifolds above ground running along the wall, and then the PEX tubes themselves will go into sleeves into the ground every foot. But for our smaller institutional greenhouses, we typically have a manifold concentrated in one spot, and we can hide that manifold in the ground in a ground covered box with a maintenance cover, of course. And when you do that, it becomes a very clean look where you see almost no piping and you don't even realize it's there. So a lot of different variations that you can do with this.
And I've also seen people install this without concrete too.
That's right. And then so with the differences with and without concrete, we can get about the same heat output out of this system either way. The trick is to do it is you raise the water temperature in systems that are installed in gravel and sand. So when it's in concrete, like I said, we typically don't want the floor to go above 95 degrees or so. To achieve that, your water supply temperature is going to be around maybe 130, 135 degrees. Combining those two together, that's going to give you a good balance. And concrete is a very, very good radiator. It has almost no insulation, so it ends up being a good radiator and radiates well. If we don't install it in concrete, say we install it in gravel and sand, or we install it, sorry, I said it backwards. We install it in sand and then gravel on top. That in itself is not near as good of a radiator. There's air pockets within there, and that creates insulation. So the heat doesn't get out as easily. But we can still heat a greenhouse space just as adequately by just turning up the water temperature. So we may run, say, 170, 180 degrees in the PEX systems if it's not in concrete, and still get that floor temperature close to about 95 degrees and about the same BTUs per square foot output in total.
I very rarely see this as a sole source heating system unless it's a temperate climate. You just can't, typically speaking, if you're growing a crop on the ground, you just don't want to force all that heat basically through the plant, right? Because it's conducting right to the plant. If you have a huge heat demand, so say you're pretty far north, you typically don't see 100% of the heat supplied right where the crop is, because again, if you end up getting into a very cold night, you end up probably overheating your crop a little bit.
That's a very good point you bring up. With all these different delivery systems we're talking about with radiant heat, in most places, like I said, except temperate climates, maybe Southern California or Florida, you can get away with one. But outside of those climates, you're typically going to pick 2, if not 3, of these delivery methods of heat for a greenhouse to complete your 100% heating profile. And then we've also seen this as well, where, going back to the forced air unit heaters type of heating, where you can do partial hot water radiant heat and then use unit heaters for the supplemental heat. Often, going back to floor heat or underbench heat, we may use the radiant heat to deliver the first 50% or so of the heat loss. And then when it gets really cold into your winter months, we'll have the unit heaters up high, and they may come on to deliver the remainder of the heat. That would be if we have that hybrid system where we use both. If it's 100% radiant heat, in that same scenario, we may have underbench or floor heat, again, delivering the first 50% of the load. And then we'll combine that with either overhead or perimeter heat or a combination of such for the second 50% of the load that's in the space up high. And those two radiant heat systems are going to be working together to complete your full heat load.
Yeah, so you kind of have your base load being taken care of by the hydronic system, which is the higher efficiency system. And then when you get into the extreme cold nights, especially let's just say you have a cold front come through that drops the temperature by 20 degrees in an hour, something crazy like that happens. Then you got your quick reacting, either overhead or overhead unit heaters or overhead radiant heat that's running at a higher temperature than your floor heat typically would be running at. So that's the best of both worlds when you have those hybridized systems.
Absolutely. And then in summary, in choosing the heating system, these are the various factors that you want to consider. And we went into a lot of these earlier with the different types of systems, but obviously the size and layout of the greenhouse is going to dictate. It may make one system more preferential than another. For example, in radiant heat, specifically the layout when it comes to the plants, if you're growing plants on benches, for example, that works really well for some sort of underbench heat. And then also even in heat pipe systems, vine crops, for example, we almost always use what we call rail pipe heat, where the carts go up and down the rails to serve the vine crops. Whereas if, say, it's in an NFT system, it would be similar type of radiant heat pipe, but it would just be called underbench. But either way, all those systems, whether you have vine crops with floating gutters, NFTs, or just plants on benches, that allows you plenty of that space underneath to run some sort of radiant heat. But if you are not growing on benches, say you're just growing on the floor, either a flood floor type system, or you're just growing on Beto buckets or pots on the floor, you can't run that type of system. On that type of job, if you're doing radiant heat, in-floor PEX heat would be your main answer to achieve that. And then also kind of going back to institutional houses, and institutional houses are primarily for people, and plants are kind of to the side. You're never going to have underbench heat in those types of jobs unless it's an R&D institutional. And that's where radiant floor heat also makes the most sense, just to kind of heat the pathways and everything that people walk on.
I'd say one of the big factors I'd say too is just the rebates on your choice. That might skew your decision one way or the other for the higher efficiency system based off of the rebates alone, especially when you're looking at retrofits.
Absolutely. And then with the energy efficiency, we went into a little bit with the unit heaters, their standard efficiency, and then high efficiency condensing unit heaters. Didn't talk about the heat source on the radiant system yet, but obviously a hot water radiant system has to have a heat source, which would be hot water boilers. The same thing exists there. You have your standard efficiency boilers. They're typically 85 to 87% efficient. And then you have your high efficiency condensing boilers that are going to be between typically 94 to 98% efficient. And those same rebates come through that way. But also with radiant heat systems where you can get another level of energy efficiency, and not so much in the efficiency of the equipment itself, but more about how you distribute the heat. In a radiant heat system, you can distribute the heat and focus more of it at the bench level and plant level itself, and design for a certain temperature within your crop canopy, but not worry about so much that temperature up high in the upper areas of the greenhouse. So you may want the plant canopy, say, around 65, 70 degrees. But the upper area, which is a different heating system that you can do with radiant heat, since it's a soft, gentle radiant heat, you can let the upper canopy area where there aren't plants go to 60 degrees, 55 degrees. And just that in itself, by allowing that distribution to concentrate the heat down low, that's going to give you more energy efficient. Because if you let the upper space get colder, there's less heat loss. Whereas with the unit heater systems, it's tougher to do because generally your unit heaters are up high, forcing air down below. So your temperature within the crop canopy as well as the upper level areas are typically going to be that same temperature.
Yeah. So kind of summarize what Jared said. There's, with the hydronic heat system,
type of plants, talked a little bit about that.
With the hydronic heat system, you're able to put the heat where you actually want it a little bit better than you are with the unit heater. And then the other, with the forced air system, that is. The other thing I'll talk about here is the flexibility to use different heat fuel sources. With the hydronic system, you have a little bit more flexibility. You could do biomass boilers. You could do heat oil. natural gas, propane, you name it, it's pretty much available to you to be able to source for heating that hot water system. With the unit heaters, of course, you're going to be limited primarily to propane and natural gas. So it gives you a little bit more flexibility in the source of the heat fuel, and you can actually even have different heat fuels to some boilers where you run this type most of the year, and then you run this type the other part of the year. There's also a difference between high mass and low mass hydronic heating systems. And what basically that's how much water you're heating inside the systems. With a high mass system, you have the opportunity to heat off of peak hours. So you can heat during the daytime if that's the only availability you have for natural gas. Let's just say there's a high demand in your territory, and you're only able to use this amount of natural gas during the off-peak hours. So you can heat during the daytime, store that heat, and then distribute it to the greenhouse over the course of the nighttime. Or you could look at these low mass boiler systems, which tend to be very efficient, but you're basically calling for heat on demand there. So you're running your boiler exactly when it needs it. So there's I would argue that there's more flexibility in the hydronic system, but of course, one of the biggest things here is going to be cost, right? Cost and budget, which we're going to talk about next. But I would argue that you have to be a certain scale before it starts to really make sense, before you start to see the ROI on the efficiency or the different heat fuel sources for the hydronic heating system versus the unit heater overhead forced air heating system. For example, I primarily work with commercial growers, and for me and my customer basis, it's a pretty tough argument to try to supply hydronic heat underneath, I'd say, about 20,000 square feet. When you start to get more than an acre, you start to really see the ROI on the hydronic heating system. We're underneath an acre. It's not that hard to maintain a handful of unit heaters.
And then finally, choosing the right heating system, proper sizing calculations. That's one of our expertise is not only installing and designing the systems, but we're always going to start with that initial heat load and then find the best system that works with your budget within the greenhouse layout. But kind of going a little bit deeper into the calculations itself, the things that you want to keep in mind are going to be the greenhouse size. Obviously, that's going to be your first parameter. Then the glazing material. There different glazing materials, of course, are going to have different heat losses. If you're looking at just single pane glass or corrugated polycarbonate, those two materials are going to be a lot higher heat loss than, say, if you have a type of twin wall material, such as twin wall polycarbonate or twin wall acrylic. And then even we can go even deeper in that. There are triple wall systems. Typically, those are only used in institutional applications, but you do get more and more returns as you use those different materials. And then going with that, the glazing material is the heat retention curtains and the blackout curtains. So the heat retention curtain, it's key. It does two things. In the daytime, it's going to be a shade curtain. We use it for shade systems in the daytime to reduce the solar heat gain and keep those daytime temperatures below a certain level. But it has a dual purpose of heat retention at night, specifically in the wintertime at night. We have two different types of heat retention curtains. We got open weave and closed weave. The open weave is more primarily it's generally just a shade curtain and has a little bit of heat retention, but the closed weave curtains have a really big heat retention value, upwards of 50-60% energy savings factor. And what that is that's going to be an energy savings factor. Typically on a single pane glazing glass system is how it's measured. So if you have a glass greenhouse, you can reduce your heat loss or your U factor of the heat going out through that roof by up to 60%. So that is another big important factor that you need to take into account your calculations, so that you're not oversizing your systems and also knowing what kind of energy usage you're doing. And also, it's going to be, the curtains themselves are going to be a much more cost-effective solution to reducing your heat load than just, upsizing your systems in the first place. And then the last thing on here, which is mentioned first, is delta T. The delta T is important for sizing. That's going to be, it can mean two things. The delta T can mean the difference between your exterior temperature of your greenhouse and your interior temperature. So again, if you're selecting, say, I want the greenhouse to be 65 degrees at night, that's going to be a different heat load than, say, you have a crop that wants to be 75 degrees at night. And then also knowing what your proper exterior temperature is. But then there's another form of delta T that's also used specifically with hot water radiant systems, which is the delta T of your hot water supply and return. You have to make sure that you size that adequately so that you know how much flow and therefore the sizes you need for your pipes in the system. And then Paul, if you want to take the last one.
Okay, certainly. So just kind of summarize all this. I mean, I tend to look at a couple different things when people start asking about heat. And first and foremost is I think about the application of the greenhouse. If you're going to just have a general greenhouse and you don't have a sense of what you're going to be using it for, then going the hydronic heating route might not be the best call for you. If you know exactly which crop you're trying to grow, you know what delta T you're looking for, and you know what kind of heating scenario you want to run throughout the greenhouse. So most of the year, I want to have this base load heat just to drive plant growth, and then in the very darkest, most coldest winter days, I want to be able to quickly increase that heat inside the greenhouse. These kind of things come into play a lot when we're talking about how we design the greenhouse for maximum efficiency, to minimize costs, capital costs, and operational costs. They all kind of come together as one big kind of collage to tell us which direction to guide you. And so talking with a professional greenhouse heating company is going to be the key to sizing and designing the proper greenhouse system, heating system for you. That would take into account all the things that Jared just mentioned, the delta T outside, the glazing systems, whether you have the energy curtains or not, often called shade curtains. And I want to mention too, you can add multiple shade curtains to a project to further increase its energy efficiency and its heat retention. By the time you add two heat curtains to it, regardless of what kind of covering you have on the greenhouse, you've almost more than doubled the R value of the roof area. So, and that's where almost 80% of the heat loss is the roof area. You could almost neglect the walls in some cases, depending on what your sidewall height is. But all these kind of help paint a picture as to what's the best way for you to heat your greenhouse system. And I would argue that there's no one size fits all. It really comes down to grower specific needs and crop specific needs. I'm a big fan of hybrid systems. I think that's a great way to reduce the capital costs and improve the operational efficiency of the system. I would say that hot water heating systems tend to be a little bit more flexible in the design. Of course, unit heaters are readily available, kind of plug and play off the shelf, makes it really easy, especially if you don't have big expansion plans or oftentimes if you're just say, for example, a retail garden center and you know that you're going to kind of be landlocked and limited to this size, then I think it's kind of hard to justify the cost of a hydronic heating system unless you're a certain scale. The other option I do want to mention here too is there's oftentimes an ability to use waste heat. If you're a large enough scale producer, let's just say you're a produce producer or a large wholesale ornamental producer, and you have a source of waste heat nearby, we can use the hydronic heating system to heat the greenhouses that way through using the waste heat or cogen. The other thing I get asked about oftentimes, I think people sometimes confuse infrared heat with radiant heat, and we didn't talk too much about infrared. It's not a very commonly used technology in the commercial operations. It may be. Sorry, but for the most part, that system's not typical in a production style setting.
Right. And then kind of bringing up their infrared is interesting as well. But I would say the biggest cons about it, it's similar type of packaging with unit heaters, and you may see these things. You may see them in garden centers and places like that. But one of the biggest cons with it is, at least in a production greenhouse with plants, is that the infrared unit heaters glow red when they're on, and that is not something that you want in a nighttime cycle for growing a greenhouse. That's the main reason why it would not be used in a production facility. Is it puts out light as it runs.
Mm-hmm. And as if you're growing a crop with a taller canopy, it's really it's differentially heating the greenhouse, the canopy. It's heating the upper canopy more than it's heating the lower canopy, because anything that's not exposed, any surface that's not exposed to infrared heat is really not being heated by it. You're not heating the air. So hydronic heating is completely different animal from infrared heating, and it's way more flexible. I'd argue way more efficient too. And you're just not gonna keep your greenhouse from freezing. You may keep the plant leaves from freezing with a infrared heating system, but not keep your greenhouse air temperature above freezing in most cases that way. Jared, do you want to talk a little bit about what we do?
Yeah, absolutely. So kind of summarizing everything that we just stated. What we do, heat load calculations, talked about that a little bit to ensure the proper system sizing. We're going to start there. That's the very first thing we do whenever we get a quote request. We always start with the heat load calculations, with the basics, the greenhouse size, layout, glazing material, shade curtain material, what kind of temperatures you're trying to achieve, et cetera. And then what we'll do is we'll go on from there. We'll design the entire heating system, and we'll customize it to your greenhouse. It's going to be customized based on your crops, your plants, what you're trying to achieve, and also within your budget. That's the key too, is there's always, a good, better, best type of levels of systems that you can look at. And then once we get a design contract, we're going to lay out all the system elements for optimal heat distribution based on your crop needs, and we'll deliver that in our design drawing package. And this will be a fully designed and engineered system, ready to go for our next step when we do the furnish and install contract, to then go and procure everything and then take care of the installation. Then, Paul, if you want to do the services.
Yeah, so of course, in addition to the sizing and the coordination, kind of we talking about what the crop's going to be and what the grower's heating plan is going to be for their greenhouse. We'll help also coordinate the control side. We didn't talk much about this, but the controls of a hydronic heating system is a little bit more in depth than they would be for a lot more in depth than they would be for a standard unit heater style system. We would also provide the installation services for the integration and support of the system. So we would come in, we would assemble the entire hydronic heating system, coordinate with the other trade folks that are on site. For example, maybe the concrete trades and the electrical trades that are putting the controls together. And of course, try to integrate that system around all the other systems that are within the greenhouse, the shade curtain system, the irrigation systems, the mixing fans, all that equipment would, by going to a single source supplier for a lot of this stuff, or working with prospects, we're designing the greenhouse, we're designing the heating system, we're working with the controls company and designing the controls, and we're integrating all that together so it comes together seamlessly, and then we don't have to worry about, we're piping a 6-inch irrigation line right next to a 6-inch heat line, and there's some conflicts there. We would be able to help ensure that there's not a problem with that. And then we give you some guidance in terms of maintenance and expansion. More often than not, we're looking at these projects and we're looking at the master site plan, what's going to take place 3, 4, 5 years down the road, trying to make sure we don't design ourselves into a corner, and that we're doing this the most intelligent way we can for the lowest cost in the future to make the expansion. So we oftentimes make these things expand. Well, we always make them expandable, at least in terms of the hydronic heating side. When you're just talking about unit heaters, we can certainly give you some guidance as far as that goes, but more often than not, that just comes down to what kind of infrastructure you have at the site, and what kind of. We don't necessarily install the gas line, so we would kind of give you some guidance as to, if you want to expand down the road, this is how many BTUs it's going to require, and then you can back into the flow rates and the pipe sizing.
Absolutely. Kind of, and bringing in the controls discussion, that's a big one. That really, the controls, if anything, really segues into the bigger overall package that bring to the greenhouse as a whole. Because, these hydronic heat systems, the controls is not going to be just for heating. That control system that my group also integrates and coordinates, it is going to tie everything in the greenhouse together. So it's going to directly control the valves and pumps and boilers and everything on that radiant heat system. Or if it's unit heaters, it's going to send enable signals to the unit heaters. That's just one piece of the puzzle. That control system is also going to control the shade curtain, the blackout curtain. If you have light deprivation, it's going to control your lights. It's going to control your irrigation system and all the various components of that. CO2, if you have a CO2 enhancement system. Et cetera, et cetera. It ties everything together.
So we have a few minutes left for questions if anyone has any. I also want to mention, if no one wants to, if some questions come up later on, that you can always reach out to info@prospient.com or go onto our website, www.prospient.com, to be able to look up we have white papers on there, and we have all kinds of different information for you to study on.
Hey guys, while we're waiting for, see if a couple questions go in, we're about at the end of our time, but could you talk real quickly about if you have a greenhouse that's already set up for forced air heating and a grower, say, wants to now retrofit it for the radiant heating, what are the costs and kind of challenges associated with that, or are there any?
I would start by asking if we're going to be growing on benches or on the ground. That's what I typically look at. It certainly takes some coordination. I mean, obviously, once you have the old infrastructure in place, maybe some of that has to be torn out in order to get the new piping in place. But it's not terribly hard to try to go back and retrofit an under the bench heat system. In floor can be more challenging, especially if you have infrastructure in the floor already. You don't want to be breaking ground and going in there and causing more damage than good. And then actually attaching it to the structure can be challenging too, depending on the age of the structure and what overhead equipment would be in there. I would say the easiest one to retrofit is probably under bench. And a lot of times when people want to go from let's just say like a cold frame or something like that to a year-round greenhouse or a 3-season greenhouse, what we see oftentimes is they just actually install the unit heaters, because that might be the easiest point of entry for them. Any thoughts on that, Jared?
Yeah, absolutely. So, things I would look at and consider is whenever you're doing a hot water radiant system, you have to have a location for your heat source. So that, because I'm looking at it from, more of an engineering and design layout standpoint. So the heat source, ideally it would go in a mechanical room, but not all greenhouses are attached to a mechanical room or even a place you can put it indoors, but that's okay. We also have outdoor rated boilers and pumps and systems, so we can actually place all of the heat source elements for radiant heat system outdoors if that is so desired. And then, like Paul said, from a structural standpoint, where are we going to run the piping? Specifically the mains. The mains are going to be your biggest piping that usually are the toughest to coordinate if it's a bigger greenhouse, because the larger the greenhouse is, the bigger those pipes become. And once you get over a couple acres, at that point, it may be, what we may be the best solution is to actually bury the mains underground just outside the greenhouse and bring it in, because those pipes are going to be so big that the structure may not be able to handle that. But we have a way to work around it. So there's all, those are the type of things that I would look at for retrofitting. That's from a mechanical standpoint. The other side of the equation is, of course, controls. Like we said, the radiant heat system is going to have to be much more complex with controls and have more control points. Make sure that the control system is up to par, or if not, what expansions or additions do you need to make to the control system to add those additional points?
Okay, well, it looks like you guys covered this topic pretty thoroughly because we don't have any other questions coming in. And as Paul said, if you have some later, we've got Paul and Jared's contact information here, or you can visit our website. We're always happy to help answer questions, things like that. So we want to thank Paul and Jared for taking us through this topic today and being so thorough about it. And thank each of you for joining us today. We hope you found this session helpful. If you'd like to watch any of our our webinars, you can find those videos on the Prospient YouTube channel, or you can find them on Bright Talk. And we hope that you'll be able to join us on October 22nd for the next webinar. So thanks again, and have a great rest of your day.
Thank you, everyone.
Thank you.